Wow, welcome everybody. Welcome to SkyTour LiveStream straight from Arizona. This is really cool. I'm here, of course, with our good friend and co-host, Daryl Mason. Daryl, how are you?
I'm good, Mark. Thank you. How are you? Hello, everybody.
I'm doing fine, thanks. I'm doing fine. Well, things seem to be doing pretty well here, and we're going to be having some fun tonight. We do have the moon coming up in a little while, but we figured why not just try to check out a few things before that happens, or even while that's happening. It should be okay. So I wanted to welcome all of you and let you know that it's a great night for stargazing out there, and we're going to keep going as long as the night provides us with an evening that's unforgettable. So, that said, here we are on our screen. This is Messier 2, a globular cluster that is in Aquarius. And it's a beautiful globular. And we're in our night vision mode, as you can see here. 1,000 millisecond exposure here. And if we zoom in on this a little bit, yeah, you can see there that that looks good. We're going to be doing a test focus. We haven't done that yet, so I will do that while you guys are here. First things first, we're going to move a little bit to the east and do so to bring a random star field, and then we will do our focus run. I adjusted the telescope. I am here in Arizona, and I was out at the building that you saw just a moment ago on the main screen. And I got the telescope optimized. There's one little quirk still, but you know what? We can live with a couple little quirks because things aren't that bad at all. In fact, they're quite good. So we will be doing our focus adjustment here. And the first thing I'm going to do is take the stars out of focus so I give it something to work with.
It's getting almost cold out down there in Arizona at night now. I was looking at the forecast earlier.
It was cold, in fact.
I don't think it ever warmed up even in the daytime. Maybe 61 today.
Yeah, it was actually chilly.
Yeah.
Yeah. Okay, and let's see. So let's get our focus tool here.
Sunny here, but 50 in Colorado Springs today, and they're saying maybe snow here tonight. So
Yeah,
and much colder tomorrow into the weekend.
that's no good. Okay, we're gonna scan in on our photo here and find optimum focus. And I've got a equation that I built that helps us keep that focus as the temperature drops. Right now it's 13 Celsius out in the building. And that should be pretty good. As you can see, our focus is going to build a curve down here. Since this is the first time using this system, are you guys able to see my cursor at all on the screen? I know you can, Daryl, because I'm sharing screens.
Yeah.
But I want to know if everybody else can see my cursor down here. If you can't, I'll work around it. Let me know. Hey, James Ireland, thank you for the compliment on the Globular Cluster.
Greg O'Brien and Edwards say yes.
Oh, fantastic, thank you. All right, good. Well, that's very, very good to know. All right, as you can see, our curve has been built, and the best focus point is here. And this will be green up here in a moment, and it's going to tell us everything we need to know. There it is. And so now we're going to move to the best focus point, and that's going to leave our stars as pinpoints. Now, when I went out there, I adjusted the telescope and I adjusted the lens system that is giving us the famous 25 times better speed photographically on our system. And this is something, because what it's going to do for us now is the focus has done something that we didn't have before, and that is it's going to make sure that the stars are focused at the extreme corners all the way in. It's a most wonderful turn of events. All right, and of course the music is all new as well. We're going to do all new music. Okay, I'll throw in the temperature compensation equation right there. And as the temperature drops, it will have a subtle change to our focus that keeps us in focus. All right, so while we're here, why not? Well, first of all, just so people know, this over here on the left, this is our telescope. Operations over here, the telescope operations system here. This is the telescope computer here. This is me down here, hello. And this is the telescope right above my head. This is actually out in the building. Both of these cameras are actually out in the building. This is the main telescope view, and this is the camera control over on the right side. This is all very important to making this all happen. Alright, so then this is our active planetarium that also is tied in to control the telescope, which is very, very cool. Now, down here is a nebula that we're going to go look at right now. It's called the Helix, and the Helix Nebula is a planetary nebula. And I told the telescope to go, and you're going to see the stars streaking around here. And this point right here is going to tell you what star we're going to be closing in on. All right, and it looks like it's going to be that one. And which star is it? I'm going to guess it's that one. It's Scat. Okay, this is the star Scat. And it's going to take us to the Helix Nebula. And then we will be able to get ourselves on that nebula and move it into position, which is the last thing we want to do.
We should go back and look at Messier 2 when we're done with the Helix.
Yes, because Messier 2 is one that we were just on, but we moved.
Yeah, we did a good look at it.
Yeah. Okay.
It's one of the bigger globulars, I believe.
It is pretty big, isn't it? Okay. So now we're going to move into the Helix now, and as I come in here, I'm going to move our telescope north and draw the Helix down into the field. You'll see it because it's big. There it is. You can't miss it. I corrected errors with the orientation of the camera, and I fixed a couple things. There's the one nagging thing that's still happening, but isn't a showstopper at all, is that it's not centering objects absolutely correctly, but that's okay. I'm not worried about that for now. There's a few things I can do to work on that. All right, so this is the biggest dead star that we are going to be looking at. Biggest dead star nebula that we'll have seen in the area around our sun. This is the closest planetary nebula, dead star, that we've seen. A planetary nebula is a very interesting location. And while I set up this to run for, say, 35 seconds, I'll just say 30 seconds. Okay. So we have 30-second exposure, doing the exposure right here. Okay. And the gain is at 300, which is a good, reasonable gain. And we actually have night vision mode on. If I turn off night vision mode, we start the countdown, and you can see without night vision, it's pretty dim. So then we're going to stack. And this is now the stacking screen. And you'll see a data curves show up here, and then these lines represent the cuts through the data curves that we're going to take, and that just shows you the, it'll show you the data, and it'll be clear in just a minute. But a planetary nebula is what happens to a star like the sun. When it runs out of hydrogen gas, it begins to shrink and get compressed. And as it shrinks, it brings more hydrogen into the core. Okay, and it could start burning hydrogen again in a shell around the outside of the main core, or it can do something else. It could start burning helium into carbon, perhaps. And when this happens, what happens is the star begins to expand again, but it becomes massive. It expands so far beyond its original size that it's astonishing. I'll give you an example. When a star becomes a red giant star, if you put it where the sun is, depending on its mass, it could go out and swallow up Mercury, Venus, and even the Earth, all right, in its size. That means that it's going to basically have a diameter of over 186 million miles. Okay, that's huge considering the sun is just under 1 million miles in diameter right now. If it became a red giant, it could be a star with a 186 million mile diameter. All right, and as stars expand, their outer envelope gets farther from the hot core and it cools off. And so the color changes. The color goes from, like the star with our sun is like a whitish yellow, it'll go to a red. Betelgeuse used to be an O-type star, a hot blue star. And it will eventually, well, it did end up going to a red supergiant because it expanded. If you put Betelgeuse where the sun is, holy cow. If you put Betelgeuse where the sun is, you would find that Betelgeuse would reach all the way out to the orbit of Jupiter. That's a massive, massive outer envelope of a star. You know, I want to say hi to everybody that's here, and I will do that now. First things first, welcome again. DK was first, Roni Hassan, Robin Curtis, otherwise known as DB Girl. Hello there, Robin. Daisy and Zoe Amethyst, Gabrielle F. Nice to see you. I don't know if you've been here before, but please do subscribe and hang out with us. CND Boy is here with us. That's wonderful. Greg O'Brien, good to see you, brother. And I want to say hello also to, we have another person here that I don't think we've had here before. I gotta find it. But first of all, hi to Vera Lucia Campos from Brazil. And thank you so much for the donation. That was very nice. Thank you so much. All right. Tim F is here. And the night is young. There we are. Okay. Alicia Vieras, how are you? Party on, Garth. Yeah, you got it. Party on, Wayne. Wait, is it Wayne and Garth? All right. Okay. Alice Pooper's with us. Zadarak is with us as well. Good to see you guys. And Edward is with us too. Papa Tom came by to say hello. James Ireland, thanks for stopping by. And now let's just take a few more peeks at this gorgeous thing. Oh, and Papa Tom, thank you. I see you sent us a donation. That's very kind, man. Thank you.
Thank you, Papa Tom.
Yeah. Okay. Anahata 77, that's Bonnie. She's here with us. All right, so let's come down here. These are the curves I was talking about down here. And this curve is the data curve. Now we're stacking images right now. And what that means is that as we actually take an image, we take the image and we take another image and align it and stack it on top. And we just keep going. And the more images we stack, the more data comes to the top. Even if it's dark and dim, if it's data, it's going to come to the top. And then we're going to lose the noise. And that's why, as you see, this image is getting better and better and better as we go on here. Better and better and better. You'll notice a lack of a few detailed things that we have going on here, only because we don't have the entire setup. We're running on a different machine entirely. I set this machine up to just run like the other. Dagger Spells, hi, how you doing? And Marianne who? Marianne who? Who's that? Marianne?
Marianne Robb.
Yeah, she's actually around the corner because we're broadcasting from the office that she does her radio show from, which is nice. She gave up her office so we could do it tonight.
Hi,
so yes.
Marianne.
Yes, thank you, Marianne. Thank you, Marianne. And hey, James, thank you, man.
Thank you, James.
Now you see, the Helix Nebula does things to people. This is gorgeous. And let's actually, let's do something. Let's go in and maximize this, all right? And I will make this something that we can keep. There we go. So I'll move this around like that. There's the Helix. Now I think that's a very, very pretty nebula. And one of the things I'm going to do right now is I'm going to darken up the image. You see how this line, this is the dark level, it's to the left of all the data curves, so it means it's going to get brighter. So if I move it to the left, it gets brighter and brighter and brighter. But the more I intersect the data, then the less of that atrocious white noise gets through, and then we can actually do this and see this beautiful nebula start to show up. Look at that. There's a lot of detail in this tonight. Look at these stars. We have far better focus than we've had, and even though it's been well focused, it's actually better than it's ever been. I would never have guessed that it could get better, but it has.
You left off with the red giant phase.
Yeah.
It's a white dwarf now.
Oh yeah, you're right. I didn't finish that. You're absolutely right. So what you're seeing here in this image, as Daryl's pointing out, this stuff here, this used to be the outer envelope of this star, and it sloughed off as the star started to expand because it started, fusing other materials into its in its core to make new elements in our periodic table. Okay, that star then expanded greatly and sloughed off outer layers. You can see one way out here. Look at that very soft fringe in the upper left of red. That was sloughed off and was moving out into space. Then this stuff sloughed off. Now, the colors mean something, which we'll get to in a minute. But what's left behind is the hot core of the star, which is collapsing. And that hot core gets to a certain point where it can collapse no more, especially because of the mass, which is about the mass of our sun. That's about the mass this star was. And what this star has in the center then is this hot collapsed core of a star that can collapse no more, and it becomes what is Daryl just said, a white dwarf. The white dwarf star is about the size of our Earth in general, and they're all pretty much the same physical characteristic items. They never seem to vary that much. So if we see a white dwarf doing something 1,000 light years away, then we know that a white dwarf 10,000 light years away is going to do the same thing. And that's very important for getting distances to things that involve white dwarfs. So, and if you notice the color of the white dwarf, let's zoom in even more. Don't get too close, you don't want to get hot. If you notice, that star is a little bit blue, isn't it? You see that? These are blue, but that one is. It's characteristically blue. The hottest things in the universe are blue. And the hottest things are O-type stars, which are the hottest and bluest stars there are, and white dwarfs, which are also hot and blue, but they're just tiny. Really cool. Really cool.
As you said, it's only the size of the Earth, but we can still see it from, I forget, the Helix, 170 light years away, something like that?
Is that what it is?
Something like that.
Well, let's go see what our planetarium says its distance is. I'm not sure that I believe it. It says, yeah, I thought it was 600 and something. It says 518 here.
Really,
So,
that far?
You have to look it up.
I know it's the closest. I thought it was closer than that.
Yeah. Well, the dumbbell is, 3,000? Something like that.
I forget offhand.
All right. Well, if you notice, though, guys, we are zoomed way in. You can see stars through this nebula. And now we'll talk about the colors. If you look at the colors, hey, Sean Farva, thank you very much. I see you're here. Shake, 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 shake your booty. Oh, yeah, it's actually shake, 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 shake your booty. He got it right, too. He got the right numbers of shakes in that statement. Well done. So the red is ionized hydrogen, and the green is doubly ionized oxygen, which is what we see in here. And this is characteristic elements that are found in the envelope of a star. And so that's what we see. Now, that's not all that's in here. There's many other elements that are being ionized as well that were made with the star when the star first was actually made. But the thing that's interesting is that this particular set of chemistry is dominated by the hydrogen ion and the oxygen 2 ion. So you end up seeing mostly the red and the green here. And that's what we see. Now, just to give you an idea just how big that is, okay, this is the size of our field. It's 4 full moons across and 3 full moons tall. All right, but we're able to zoom way in because we're stacking and getting rid of a lot of the noise. And you'll see that by stacking, we're also taking 35-second exposure or 30-second exposures that aren't even drifting in the slightest. They're not oblong stars. They're perfect, and it's really pretty. Wow. Hey, Fantasy. Yeah. Fantasy says I never got the notification. They even resubscribed just to be sure. I don't understand how the notifications work. When you do click the bell, there's a drop-down menu there. Also select all notifications in that drop-down. Okay, that's going to help. I don't know why it does what it does. I just can't tell you why. I don't know. All right, let me see what it thinks it wants to do for image processing. Yeah, see that's called a push, where it's actually trying to bring all the data out, and it's not as good. So I tend to soften this a little bit so you can see data better. Yeah. And now what I'm going to do is I'm going to add one more touch. I'm going to add what's called an unsharp mask. And if you watch the screen now, watch in here, right around, like right here. Watch the details that may well pop here when I do this. Here we go. Ready? Here we go. Unsharp mask is on. Look at that. Do you see how these clouds are even more well defined now? That's pretty cool. Adding the unsharp mask at the middle of the exposure is a good idea, because then the noise isn't getting amplified by the masking process itself. Nice though, huh? Wow. This looks nice. Okay. Let's do a color compensation here. See, when we actually do a color correction, more of the nebula is visible. So now you can see that there's a wave of material here, a wave of material here. There's a wave out here, and there's another wave out here. Okay, so that is something. I'm going to, up here now, in this box, I'm going to put in Helix Nebula. Now, why am I doing this? For those that know, don't tell anybody else. No, what I'm doing is, by putting a name here, what we're going to do is we're going to save this. And when we save this, okay, let me bring my telescope back here. All right, there it is, the telescope right there. Okay, when we save this, what's going to happen is it's going to go into a directory that you'll have access to in about 30 seconds. So right now, if I hit save, all right, you're going to see a green line come across that says that this name of this stacked set of images .fits, that's an astronomical file format that you can download and do work with if you want, or if you just want the pretty picture, I will save it exactly as seen, and you'll see that the next line shows it as a ping file. You can double click on that and it'll come right up like you see here. Okay, the ping file is going to be what you'll see on the screen when you go to the database. And where is the database located? The database is located at SkyTourLive.com. And if you go scroll down in SkyTourLive.com, you will see exactly that. All right, you'll see a link that'll take you to the website. I'm sorry. Well, there's a link to take you to the database. All right, and that's what you want. Okay, so it's SkyTourLive.com. Okay, that's what it is, and I shall change that around here in just a bit and make that available to everybody so you can see it. All right, so that's gonna be right here. So everything that's done tonight, you can find on this is our portal. You can find everything up on our portal at SkyTourLive.com right there, and you can get to hang out, see these beautiful images, and do whatever you like with them. They are free. And Daryl put a link in the database to the server. We we manage this server and we try our best to make sure that the server is up 24/7. It usually is, and you will be able to download it, download anything on the server, and that's all for you because we think you're the best. All right. Okay, so visit SkyTourLive.com and get all this beautiful data. And SkyTourLive.org is also available as well. This is beautiful, Daryl. Look at this.
Can we go big again and zoom in a little bit?
Yeah, because I'm thinking we want to. All right. Let's just do this first. All right, I'm gonna zoom in. Look at all the detail in here, guys.
See detail in the clouds around it, and some of the those radial
These guys.
radial things are showing up.
Yep.
Yep.
Those radial things Daryl's talking about are little stalks of material that was blasted off in all directions, and it left them in long linear radial lines out from the center of this slow motion explosion. How nice it is.
It's very nice.
Wow. I'm very happy with
A lot
this.
of detail in the clouds tonight.
Yeah. Which means we should, before long, we should actually head up to Measure 33. Okay, so we've stacked 34 of these. So I'm going to pause the stack here. I'm going to save it again and save it exactly as seen. And that's also going to be in the Helix Nebula directory. In fact, as we speak, it's already being sent up to the cloud where it's going to go out to the server. Daryl put the link in there, but you can also find it here at skytourlive.com. Scroll down and it'll say, take me to great pictures, and you'll do that. Go down a little further and you can get photographic prints of everything we take as well. On metal, on canvas. In fact, here there's probably 10 or 15 of them hanging on the wall. They're just absolutely astonishing. I was so humbled to see how beautiful they come out. Very, very nice. Okay. Now, let's...
Going to Messier 33, can we stop at M2 first?
Yeah, we're going to stop at M2. So I'm going to clear this now. It's been saved. And I know it's gone. You say, oh no, it's gone. But don't worry about it. It'll be back. It'll be on the database here in just minutes. Okay, so right now we're going to go back to our 1 second exposure and our night vision mode. There we go. That's our night vision mode coming up. There we go. I'm going to zoom out now. We're at 144% on that. How about that? Okay. Okay, night vision mode. The green, as you might expect. This is the Papa Tom. It's a nebula, but it's called a planetary nebula, which is the remnant of a star like the sun that dies. A supernova is a remnant left behind by a star that exploded, and those are anywhere from 10 times the mass of the sun to 30 times the mass of the sun. Betelgeuse is one, Rigel's another, Alnitak, Alnilam, Mintaka are others. Bellatrix is one. So one of these stars, it will go supernova. So in other words, Orion is going to change forever in a very short time. Hello there, David Schmidt. When I say short time, I mean in the next few million years, because that's as long as those types of stars live. Okay, by request, we're going to go to Measure 2. Measure 2 or the Pegasus cluster? Which one?
How about both?
Okay, I'm trying to get to these before the moon rises on us.
Yeah.
But we'll do Measure 2 because that's where we were before.
Okay.
Alright, back to Measure 2 we go. Off we go. You'll see the stars streak away here. Oh yeah. One of the people in our streams liked hearing the sound of the telescope when it moves, because it does go. It's really kind of a cool sound. Okay, that's our waypoint star right there. and the waypoint star is going to be maneuvered, and then we will be able to have the Measure 2 brought right in. It'll be very simple. Hey Jess, Jess S is here. Jess S, present. Good for you. Thank you. And Papa Tom, that's no problem. I'm very happy to clear that up for you. All right. And once the telescope stops and gets into its final mode, there we go. We're tracking. Now what we can do is bring this up and bring Measure 2 right down into the view. Here it comes. Ta-da. Very nice. It's a very pretty cluster.
Yes, it is.
And we will zoom in on this too. We'll take this, we'll do a short stack on this one. So what's going to happen now, if you look right up there, you'll see that it's searching for a guide star. When you start to see numbers showing up here, it shows that we're actually guiding. And that's something that's very important. Once we're guiding, then we'll be able to actually take pictures, right? So that's what we're going to be working on. All right, so we're guiding now. Alrighty, so let's go do a 25-second shot of this guy, and we'll come out of night vision mode now and go into a stacked mode again and just do a short stack on this guy. And we'll change the name here to Messier 2. And I'm going to put GC after it for Globular Cluster.
I knew you would.
You betcha. I didn't put PN for the Helix, but I will. Okay, there it is. And check this out. We're going to see what we do here now. There we go. Now I noticed that it's really bright. And so in order to get detail in the middle, you might think, oh, it's all blown out photographically. But it's not, because what we can do is this. This camera has the most amazing capability to show us things that seem hidden. And we can get down to the individual stars in there, or we can pull it out. And I'd say that this is probably about good right there. There we are. There's Measure 2. And we can actually zoom in on that a little. Yep.
That appears to be a very condensed globular.
It does. And we can actually chop away at more of it.
Some people think globulars all look alike, but that's not true. They each kind of has its own character to it.
They do. D.
Bigger,
Smith,
smaller,
hello.
brighter, dimmer. Some very condensed, some very loose.
David
Sometimes
Schmidt.
you can see patterns inside them too.
You can, like in the Measure 13, you pointed out the propeller many times to everybody. Yeah.
13 has propeller. M4 has that kind of a vertical bar, stars across the center of it.
Right.
They're all different.
Yes, they are. They are all different. Okay. Alright, there's the short stack. We've done 5, and we're going to stop it at 6 because we want to move to the next item, the next vast, amazing galaxy. Saving it now. Saving it exactly as we see it. Alright. So there's Measure 2. And now, guys, let's take a journey to a galaxy 2.6 million light years away at least. Okay, so we're going to clear this. Go back to 1 second night vision mode. Alright, let's do this, and we'll get rid of the stack.
Thank you for indulging me.
Yeah. Alright. Okay. And now we'll bring up this planetarium system. And up here now, we're going to go to the next object I talked about. And you don't see it yet. I mean, there's the Andromeda Galaxy there. And that Andromeda Galaxy is fun too. But we're going to go to the Triangulum Galaxy first, and then we'll go to the Andromeda Galaxy. What do you say to that? Good?
Sure.
All right.
Oh, yeah.
Okay, here we go. Onward, telescope. Onward. Hey, Rascally Rabbit's with us. I'm surrounded by blue mods. Oh, Rascally, if you were here more often, you'd get a wrench. It's really good to see you. David Schmidt says, "Do you have your sword?"
My sword?
Yeah. We're gonna zoom out a little bit now. Here we go.
Whoops.
Yeah, David Schmidt, never mind. That's funny.
I don't get it. I
Well,
have swords.
of sorts. Okay.
Well, my brother, my twin brother, graduated from the Air Force Academy. I have his cadet sword.
Ah, okay.
Sort of a saber, and it is a
Yep.
saber, I guess. And
Yep.
I have others.
I have a couple of sabers myself.
I have a cool sort of a head chopper's sword that I made for Halloween many years ago. Made out of wood, but it looks cool.
Wow.
I scared a lot of kids with it.
What a kind person you are.
It's part of my costume for that year.
Yeah.
It was way back in the 90s.
Okay. Let's see how well we have it centered here. That's pretty good. I have to update that part of it. Okay. So now what we'll do is as you can see, we're guiding. You see that the numbers started to change over here. Okay, and that's very good. That tells us everything we need to know. All right. So now that we're guiding, I can set our time here to 30 seconds once again. And off we go. Now, because I haven't changed over to stacking mode right now, you can see this down there. You can see that progress bar moving over here. That progress bar, it's not going to read off the data from the sensor until it gets all the way to the end. So we have time. So I'm going to set up the live stack now. There we go. I will clear this last bit of data on there. And we have 4 seconds now. And watch this. There is the beautiful Triangulum Galaxy. Alright, let's zoom in on that a little. And you're going to see that there's quite a lot going on here. We're going to try to bump up the contrast a little bit. Yeah. You can see these greenish areas here. These greenish areas are very important. These greenish areas are areas where there were supernovae in this galaxy. Okay, so there's one, there's two here. You'll see more come out soon. And there's another one down here. Okay. And you can see my cursor, is that correct? Is that what you're telling me?
That's what people said earlier.
Okay, then they should see it. This is a gigantic nebula complex in this galaxy. And so is this. Okay, both of those dwarf the Orion Nebula in our own galaxy. Hey, Nodder, how you doing?
Yeah, that object up at about 10 o'clock from the center has its own NGC number. It's so big and bright.
Well, there's many of them in here.
NGC 604.
Yeah. Let's do a color correction, and that may help us. Okay, see, the color correction shows us now the bluish arms of the galaxy with the reds of the areas within. This is a beautiful enough object that we're going to go and make it big. Let's do that, and then let's do this. Okay. Now that is an object. Wow. Hey, Ahmed, how are you? Nice. Hey there, Walter Beagle. How you doing? Yeah, David, I'm actually in Arizona right now, and I'm broadcasting from Arizona. I'm actually about an hour and a half from the building. Normally when I'm broadcasting, I'm 2,500 miles from the building. But I was just out there yesterday. I did some work on it, and one thing that's not immediately obvious, but you can see the stars are round all the way into the corners. That means that our focus system has been made far better. There's a few little nagging things that we're going to get rid of. We're already looking at a potential different camera, and that will take care of problems that might crop up. I'm going to actually get rid of some of the background now. I'm going to intercept our curve, and things will get darker with more contrast. Look at that. Wow. Now, is that a galaxy, guys, or is that a galaxy? That's really pretty.
It looks quite different to me than when you've imaged it before.
Yeah. Well, let's try to see what it wants to do. Okay, this is what it wants to do. You know, this is how much data is really there. But I'm keeping the noise tone down by just going like this and pulling the noise down just a little bit. See?
Yeah, it looks nice.
Look at how many red spots are in here, guys. These are all NGC objects, that new general catalog objects that have been cataloged in this galaxy. Look at how many of them there are, Daryl. There's just so many more that we can see tonight than we've ever seen.
Oh yeah.
So I'm gonna actually measure 33.
I see one of the green objects we've seen before. It looks maybe a hair less green than in the past.
This one?
Well, that one. Then I was looking at the one over at about 3 o'clock right there.
Okay.
Yeah, the colors look a little different.
Maybe. But down here, there's another green one right here.
Mm-hmm.
These are all supernovae that actually were bright enough to be seen here. So that's pretty cool.
Pretty picture.
It is gorgeous. Mm-hmm. Wow. I think we can probably even darken just a little more now. Take out a little of that bright sky background. Here we are. This is actually quite good color rendering. That's really good right there. Look at that. You can see the blue of the spiral arms. This is where young hot stars are born, in these blue arms. Wow. All in 30 seconds, guys. Isn't that something? Hey, Dude W, how you doing? That's amazing. I've never... I know I say this a lot, but this looks like the best version of the Messier 33 we've ever taken. I say that a lot, don't I? Like, each one's different. This one's better. No, this one's better. I'm going to save it now, just like this, and then save it as seen. And we'll keep going. Wow.
I don't know what's different, but it's different. It's a very pleasing image.
Yeah.
Maybe a touch more red.
Oh, we're seeing the H2 regions far better. The color rendering is better. Let's go see, though. Let's go see if that's because, or being influenced by, the fact that the moon might be up. Yep. See, the moon is up. The moon is up. So we're getting a bit of an influence from the moon. But it's not bad, though. It's looking pretty good. You know?
Can you go back to Spheriá for a second?
Yeah. Wow.
Yeah, you see the moon right next to Mars there, in the horns of Taurus the Bull.
Mm-hmm.
That's what we're going to see next month.
Yeah.
When Mars is at opposition, the moon is going to be right next to Mars and pass right in front of it.
Wow.
And Mars has begun moving retrograde now too. It's moving east to west in the sky as the Earth catches up with it, as we both orbit the sun.
Yeah.
Heading toward opposition. Okay, thank you.
Sure. I'm telling you, it's like there's so much to see. Look at all these stars. Look at these beautiful hot young stars here. Look at these stars here. These are associations of hot young stars.
If you look at the spiral arm below the center,
yeah,
it looks like there's quite a row of H2 regions there.
Yeah, like right here.
Yeah.
And a supernova. Yeah. Look at all the dark nebula in there too. Boy, this is something. Wow. Alright, let's try to bring out a little more detail in here.
You seem like you're capturing red better than you used to.
Yeah. Yep. Yeah, the sensor is really performing well. You can see this blue outer rim here. That's beautiful. Look at these gorgeous supernovae here. One here, there's one there. Then we got this really cool arc of stars right here. You see that? That's amazing. We got another supernova right there. We got another one right there. We have another nebula right here. Vast amount of H2 and, star forming regions in here. Gosh, this is so beautiful. Let's go back to what it thinks is good. First of all, let me just color balance what it thinks. Yeah. Okay, that's the proper color balance there. Yeah, see, it wants to put too much emphasis in there. That's not the right the right balance. So we'll change that to what we know it should be. Okay, now move this down a little bit. Okay, it's a little too much. Now move it down. Oh yeah, that's really pretty. Man, that's really stunning. I have to zoom out a little bit. I mean, we're actually, if we go to 100%, okay, this right here, this is the native size of the sensor. This is what it's best it's showing you. Okay, if we zoom out a little more, now we're at less than the size of the sensor. This is 70%. And the galaxy is just barely in here. Hey, Daisy and the cowboy. That's Mike and Daisy. How you guys doing? How's Florida? Hope you're avoiding the hurricane. Oh man, we've got 24 stacked. We're going to go to 25 on this and then move on. We'll go to Andromeda after this. Why not? It's right nearby. All right. Okay, let's pull this here. Let's bring the telescope back into the view. Here we are. All right. We're going to pause it now. Save it. Okay, we saved our raw file. We're going to save it exactly as seen now. All right. Done. Fantastic. Okay. We'll clear that next time we come in. And first things first, we're going to go back to our 1 second shot and do a night vision. Give us our night vision mode back here. There's night vision mode. And bring us back down to just about the size of our sensor. There we go. All right, that's a little too much. There we go. All right. Now, get the computer up. Here we are. Daisy says the hurricane was a disappointment for Michael. It would have been his first. Well, your disappointment is everybody else's salvation. So be happy you didn't experience the worst. That's like saying, I want to experience an earthquake. And then you get a magnitude 8.
Some things you just want to see from a respectable distance.
Yeah. Rascally Rabbit, thanks, man. You have a great night. Enjoy the hockey. Okay, let's go here now and move ourselves just upriver, just a little bit, to the Andromeda Galaxy. Here we go. I heard that.
Sorry.
Oh, it's fine.
I haven't got used to the time change yet.
Okay. I hope you guys are having a good time tonight. I sure am.
Oh, yeah.
This is our Andromeda is Coming music. Let's go see it. Oh my. drifting into our view, just over 2.4 million light years away or so, is the Andromeda Galaxy. The closest galactic neighbor to us other than the Magellanic Clouds. And a galaxy that is heading right for us. In a few billion years it'll be here, and it will pass through our galaxy, disrupting forevermore the shape of our galaxy, turning us into one of its satellite galaxies, and or subsuming us and consuming us. And we will be part of that galaxy moving forward in time. 30 seconds. I see we had a little breeze right there. You saw that wind. Okay. Now that we have that settled down, let's wait for our Starlock guide to search and find a guide star. And we'll see numbers appear up there. And then we will know that we'll be ready. It takes about 14 seconds. There's the zeros, the calibration, and boom, we are now guiding. So off we go. We're stabilized, and we're going to start off with a 30-second shot. And we'll do it in a live stack and clear the Measure 33. See how big Measure 33 is? Okay. Take a look at this and then compare it to what the Andromeda Galaxy looks like in a few seconds. Okay, so we're going to clear this now. And now the Andromeda Galaxy. Look at the difference. Okay. And there we go.
That looks a little warmer too than it used to.
It shouldn't be. I gotta fix that. I didn't do any color correction. Here's a color correction. Okay, and I can see that I didn't quite wait long enough, so we're gonna clear that. And we're starting a new stack. I started this, I should have let it stabilize. I didn't let it stabilize. Sometimes it dances around a little bit once it starts guiding, but it stabilizes. So this next shot will probably be perfect, unless it's windy. Yeah, it looks like it's windy out there.
Oh.
I did see that. I saw that it was windy.
It's been windy here too.
Yeah. Well, if you look at the telescope, look what it's looking at. It's a big, giant, catcher of the wind.
Oh yeah.
What do we get? Okay. That looks like it might be all right. When the moon is up, images do tend to take on a redder cast because the moon is altering the brightness of the background ever so slightly. This is the beautiful OB associations down here. See this cloud of stars? Hot young stars down here in this galaxy are just pummeling it with radiation. Absolutely pummeling it with radiation.
And as ever, it bears mentioning that we actually see 3 galaxies in that image.
That's true. Let me bring those down so you can show people. We got this one, Measure 32.
M32.
And then this guy.
M110.
Yep. and of course measure 31. Interesting thing about these types of galaxies, guys, is these elliptical galaxies like this. One of the things that you'll notice about these galaxies is they have very little dust in them. Notice the Andromeda Galaxy has this dust. All right, this is a spiral galaxy. They're filled with dust. For some reason, elliptical galaxies have no dust any longer. Why? It's a great mystery. We don't know why. Did they pass through another galaxy and have it stripped away? Did the Andromeda Galaxy strip away dust from these galaxies in a pass-through at one point? Is this what the Milky Way is destined to be at some point? A satellite of the Andromeda Galaxy with no more dust in it because the Andromeda Galaxy eats it all. Who knows? No one really knows. We don't understand that. And hello to high alpacas. Very nice. Hey, hey. Yeah, the blood moon eclipse. We wanted to stream the eclipse with the main screen or the main telescope camera, but we had a cable failure out there that prevented the camera from talking to the telescope. So I went out there yesterday and replaced that cable with a very, very heavy-duty cable. So I do not expect there to be any failures again.
Did a cable wrap happen or something?
No, it was actually the cable that was the USB cable that was connecting the camera to the USB hub, which then goes to the PC. That cable seemed to be of lesser quality, even though it came with the camera. So I had to replace it. And that's all I could do, unfortunately. Look at this. Yeah, the wind's affecting us a little bit, but look at these beautiful hot blue stars here, huh? Those are pretty. And the Andromeda Galaxy has its own share of nebulae, which we can kind of see them, but we're getting some wind tonight, so we're not able to see. You can see one right here. There's another one up here, right there. Another one right there.
Wind must be getting worse. The stars were nice and round earlier tonight. Now they're getting oblong.
Yeah, it's just because of the wind. But we have some beautiful dust in the center of the galaxy. Hi Alpaca says, well, I plan to still be watching your stream in 2026. Well, we may have some surprises for you as well. Because we've originally were talking about a second telescope to go in the same building. But it looks like we may be adding a third observatory to our collection. So I'll let you know more about that as we move forward. The more locations you have, the more chance of clear nights you have. Okay.
So not a third telescope, a third observatory.
With a third telescope.
Yeah.
Yeah. And what will go in this telescope observatory, I'm thinking will be a solar telescope. So we can also do daytime work as well. The idea is to be able to do 24/7 observing, whether it's the sun, planets, the moon, or the stars or the deep sky. And for that, we need a variety of tools. While I'm here, I'm going to zoom into this because I want to show you. When I talked about the dust, you'll notice in this galaxy there is a tiny bit of dust in here. You see this little dust ring? There is some dust in ellipticals, but it's very, very little. Most of the dust is gone. See, it didn't take but 2 or 3 exposures that had wind in them. And the reason you know it's wind, if we zoom right in, I can show you, is because the image is sort of dragged out at the end. See that? It's not just oval. It's dragged out, kind of like in a faded looking view, or faded looking manner. This is characteristic of a telescope being bumped and moving a little bit by wind. So the image is overblown a little bit, and it comes back the other way and just bounces back and forth a little bit. And this is just about where the wind, it makes sense because the wind is coming kind of from a direction to catch the open mouth of that tube.
Can you go back to 110 for a moment?
Sure.
I never noticed that dark arc there before.
Yeah, that's the dust that's in M110.
Yeah.
Kind of cool to see it, huh?
Yeah.
We're not used to seeing that in ellipticals.
Well, I wanted to go back to it.
Yeah. And if we go to 32, if there's dust, well, we're not going to be able to see it because it's quite a compact object. But I don't think there's much dust in here at all. But we can actually drill into the core by doing this. And I don't see any dust. I do see that the core is somewhat overexposed because of our handling. All right. Well, there we go. I would normally save the Andromeda Galaxy, but because it has the star elongations, I'm not going to. It's less than optimal tonight for that. But we'll just check out other things. Okay. Let's go see what else we want to do here. We did Triangulum Galaxy. What's over here? Bring up our other lines. Here we go. All right. This is still a little too low for us to see. If you see the back side of the building there, right? That back side of the building is the northern side, and this is the eastern side. That's the side the building opens to. And the reason that telescope is kind of skewed toward that side is because it's going to give us our north, northwest, west, southwest, and southern horizon better than the east. Now the east is toward Phoenix, which is about 70 miles away. And that 20 miles, or sorry, that 70 miles away means you don't see light except for the cameras. With the cameras, you can see lights, but it's very, very faint. But still, it's too much. Hi, alpacas. Thank you. That's a wonderful idea. He says, that's awesome. You plan to get another location. This isn't much, but I hope you can. I hope it can you into the future of teaching, explaining. Yes, sure. We'll be able to use it. I appreciate that so much. Thank you. We're very humbled by you guys coming out here and enjoying us tonight. Oh, yeah. Well, you know what? I said I wasn't going to save it, but you know what? That goes against my approach here, because you never know what you're going to see. Here's measure 31. We've done 22 stacked. We'll pause it here, and we'll save it. And we'll save it exactly as seen. Okay. There it is. So now we can clear it, end the stack, and go back to night vision mode. The reason I'm here at all, by the way, is because I was teaching astronomy in the desert, and it was for a boot camp. We had Navajo Rangers, John Dover and Stanley Milford, and they were here teaching everybody their tricks of the trade. And it was just a wonderful weekend. They weren't the only ones. There was a few other people teaching as well, all good people, including Marianne and Dave. Dave Rich was teaching as well with Marianne and myself and Katie and Shane, John and Stan. Yeah. And I see the wind. And look at that. See that little one? That little... I'm not doing that. I'm not touching the telescope. It did that by itself. If I touch the telescope, this is what you'll see. Okay. You'll see it move a little bit like that. Okay. So let's go check out another object if we can. What should we look at now? Let's go back this way. Here's Jupiter. Where is Jupiter?
Jupiter's in Pisces.
Yeah, no, I know that, but I'm saying where is it in the sky here relative to where I am? Yeah, we could look at Jupiter. Again, this telescope is not the best to look at planets with because it is a telescope that is meant for looking at deep sky, large fields of view. You'll notice the telescope is swinging around now, and then it's going to be staying pretty high in the sky for Jupiter right now, because Jupiter is pretty high in the sky. So I'd like to see how it might look. Let's
Excuse me.
no worries. You see that glow right there at the top of the screen? That's Jupiter glowing very, very brightly into the field. And you can see that we're just going to move ourselves up. Bring it in there. Hello, Cindy Murphy. Good to see you. Alright, so let's bring Jupiter down into the field here. You'll watch that glow get a little brighter. Jupiter's a very bright planet. It's also one of the largest planets.
One of? It is the largest planet.
Well, yeah, if you want to count Saturn, the second largest, you know. It's not actually a planet that's largest of the planets that we've found around other stars too.
Well, it's largest in our solar system.
Yeah, there's planets out there that are many times Jupiter's mass. Okay, now for this, our simple night vision system is just way too much. Now if we cut it down, okay, like this, and drop our, let's bring our exposure down to, there we are, let's zoom in now.
Oh.
You can see 4 moons now.
Yeah, 2 of the moons are right next to each other.
Yeah.
Well, they look right next to each other. They're not.
Correct.
They're in the same line of sight.
Right.
Give me just a second and I'll be able to tell you which one is which.
I bet you we can do that here as well. Let's zoom in and see. Yeah. Okay, so the one that's above Io is above Callisto, and then it's Europa and Ganymede. So Io is this one, and Callisto is this one, and then Europa is this one, and Ganymede is this one.
Yeah.
Let's drop the sensitivity, because that'll reduce noise. And let's check out Jupiter without.
You know, that is a line of sight only.
Yeah.
Io is the closest moon to Jupiter, and Callisto is the farthest.
Mm-hmm.
So they're in different places in their own orbits.
Yeah. Okay, let's zoom in and see if we can see any cloud bands. Again, this isn't the planetary telescope. We have other scopes to do that. Oh, look at that. We can see cloud bands, though. Actually, it's not bad tonight. That movement is because of the wind just flipping the telescope around. But you can see, we have one cloud band and another one down here, and we might even have a red spot in here. Can't really tell right now.
Yes, actually you can. The red spot is over toward the lower right edge of Jupiter at the moment. I just posted a link in chat. It says shallowsky.com/Jupiter. That's JavaScript Jupiter. That will give you a real-time look at what Jupiter and its moons has to show us at any time.
Very good. Thank you, Daryl.
Yeah. The great red spot is presently down near the lower right.
Right here.
Yes, lower right edge of the planet.
Seemed like we could see something. All right, now, guys, this doesn't even compare to what Jupiter would look like once we actually use a regular telescope that's designed to look at the planets. We're using a very wide field telescope, and the fact that we can see any bands at all in any clarity whatsoever isn't bad. This is actually pretty good. It's sort of a testament to the clarity of the night sky out there. The little bit of wind we have is precluding us from taking any real good pictures, you know. So that's pretty cool. Neato. All right. Well, if we increase the exposure a little bit, we'll start to see the moons again. And we have to do that in order to see the moons. But you'll see how the brightness of Jupiter certainly makes it difficult to see the moons. See, 1, 2, 3, 4. We got them right there. This is Io. That's Callisto. Okay. Io should be a little bit more orange, and I bet you if we were to move our exposure time up just a bit, we might be able to see that.
When we see them, Io is closest. Io is a hot moon. It's the one that's a sulfur yellow color, and it has volcanoes on it. And of the three in that row up top, next one out is Europa, and it's also truly the second one out after Io.
Yeah, and then this is the biggest moon in our solar system right here.
Ganymede.
Yeah.
And Callisto. And when we see Europa, Europa is the one that is the icy moon. That it's covered in sheets of ice, and they think it may have a liquid ocean under the ice.
Oh, yeah.
And then Ganymede and Callisto are the ones farthest from Jupiter, and they're cold, semi-rocky bodies, I guess. They used to think they were rocky. They may have ice on. They're also icy to some degree, I guess.
Yeah, they are. Ganymede and Callisto have ice mantles on them as well. So I have a feeling they're going to discover that the same possibilities for Europa exist for Ganymede and Callisto. Okay, I think that Io, and Fantasy, I'll address your comment too in just a sec. Io being a sulfur predominant moon, it's really cool because Io, when it's on the sun side of Jupiter, where it's getting sunlight, we actually see a whole lot of sulfur that is making basically a small atmosphere around Io. And then when it passes behind Jupiter and goes out of the sunlight, that sulfur rains out of the sky. So every time Io goes around Jupiter, its atmosphere rains out to the ground as frozen sulfur and sodium atoms. It's just incredible. Donald Kunzer says, Marc, is Ganymede in Io's shadow? No. This is Io, this is Callisto, Europa, and Ganymede. It's very rare for the moons to shadow each other, in fact, and I don't think they do. But Jupiter can be shadowed by Io. You'll see Io's shadow on Jupiter. And that is something that with the other telescope we'll be able to see. Yeah, that's true, Fantasy. Yep, the optics and setup, we made some choices. And among those choices was the choice not to go planetary with our telescope, which you already know. I know you know that. But you're absolutely right. You don't need to have a big fancy telescope to see Jupiter like this. The reason is because it's so bright. You just need to have some reasonably good optics. And if you have some reasonably good optics, then you'll be able to see Jupiter way better than a much more expensive telescope. All right. So yeah, don't think you need a telescope that costs thousands of dollars just to see Jupiter. You don't. You can go to Walmart and buy a simple refractor and look at Jupiter and be amazed. All right.
Not that I would counsel anybody to go to Walmart to buy a telescope.
I know, but if people want to learn about them and people want to grab one, then, well, that's what you can do.
The whole thing about department store telescopes.
Oh, yeah. Absolutely. No doubt. All right, so. Okay, so there's Jupiter. And let's go and see. Let's go here and let's go see now if there's something on this side of the sky that'd be kind of fun to look at. Figure while we're here, we might be able to check out this. Let's see.
Mark, Mary Knasinski has a question.
Okay. Hi, Mary Kosinski. How are you?
Able to address?
I'm still a little confused. I admit about why you can see details in distant galaxies, but not the great red spot on Jupiter. All right, very good point. Our telescope is a telescope that has a very wide field of view. So when we look at galaxies, the galaxies are much bigger than Jupiter's red spot by far. In fact, they're way bigger than Jupiter itself. If you notice, Jupiter on the screen is, I'll even do it here. Here's this tiny dot of Jupiter. And we're zooming in a lot to see details there. All right. But galaxies cover this kind of territory on our screen. If we zoomed in as much to see a great red spot sized thing in in a galaxy, then it too would not be as clear. Now we're trying to do something about that too. There's another camera that we could use that might actually allow us to see things far better when we zoom in. And that's a possibility that we can take advantage of here. So we're looking at making some changes and upgrades. So I hope that helps you, Mary. But if you notice again, the galaxy we looked at was way bigger. In fact, let me just zoom out a little bit here, even more. Okay, the galaxy we looked at was kind of like this big. And when we zoomed in, we didn't zoom in farther than about like this in that galaxy. All right, we went to just about 100%, okay, which is here, all right, and we went to 140 in one particular case. So this is why the details look the way they do with our telescope. Again, it's a deep sky telescope.
Which means low power.
That's right. Low power, wide field.
Oh.
And fantasy. Go ahead.
If you want good views of planets, especially like Jupiter, Saturn, Mars, what you want to look at those are pretty high powered.
And more focal length.
Well, yes, they go together.
And so, and in effect, Fantasy says it's like playing with binoculars. You keep changing the focus, but what you really are doing is changing the ratio of the distance between lenses. Marc's telescope is configured for distance. It's actually configured for wide views, large swaths of the sky. And this is why, and it's actually running 25 times faster than other telescopes of its type. So we're actually able to see things with much higher levels of detail much, much quicker. But tiny details could get lost. Now, changing the camera might be something we can do. There's another camera that I'm looking at that might be a better camera for this telescope. And we're looking at that possibility. And maybe we could use this camera as a guide scope on the other camera. So we'll see. We have a lot to consider. We're putting together a brand new package right now, and as I said, it's either going to be, well, very possibly another location entirely. So we have more clear night options.
Looking at planets is different too, in that one of those cases where looking by eye, you're liable to see more than you will on a video camera or a planetary, an astro camera like this. When you see images of planets without processing, they just look pretty blurry and you don't see a lot of detail. If you look by eye, well, the seeing changes moment to moment depending on how turbulent the air is. But at crisp moments of seeing, just tons of detail will jump out at you by eye. And to really get good images of planets, they will video the planet and get a whole bunch of frames. And then they'll stack only the best frames to build an image, a processed image.
Yeah.
And that's when you see tons of detail come out in imaging of planets. And those, you can see more then in the images than you can by eye.
Mm-hmm.
But just visually, at moments of good seeing, good air, you would be amazed how much you can see by eye on planets.
Yeah.
You need high power though, like you're probably talking like 150 power magnification.
Yeah. I want to say hi to Cremos, C. Ramos. How are you? C. Ramos. Welcome to you. I see you're watching from Chile. Welcome to the channel. Please subscribe and hang out with us. We have over 600 streams online right now, all like this, where we look through this telescope right over my head. You can see it up there. We look at the night sky and check out wonderful objects like the one I'm just going to zoom into or pull into now. This one we're going to see here is a globular cluster known as the Pegasus cluster. There it is.
Yep.
So thank you very much.
Pegasus cluster after all tonight.
Yeah. I assume that's your name begins with a C and your last name is Ramos. Is that correct? I don't want to get things wrong. Let me know your name so we know what to call you on our channel. Okay, so this is the Pegasus cluster, and looks like we're getting Claudio Ramos. Okay. Well, nice to meet you, Claudio. Yeah, look at that. That's pretty. You can zoom in on this too a little bit. This is our live 1-second view. You can see the stars dancing around from wind. We're getting some wind out there, which is why they're doing this like this. We can actually drop our sensitivity a little bit and lose some of the noise. There we go. Look at that. That's better.
Can you go to Stellarium for a moment?
Mm-hmm.
Pull up the info.
Okay.
M15, okay.
Yes. The wind is making it impossible for tonight for taking pictures. Es la verdad. Hola, Claudio. He's in Viña del Mar. Okay.
So this is Messier 15.
Yes, it is. Yes, it is. See that, Claudio? Everyone's saying hi to you. That's because we have a wonderful family here at SkyTour LiveStream. I hope you come back again and again and hang out with us. We love doing our night sky.
Yeah, hit the subscribe button.
He did already.
Oh.
And Marianne is back saying hi to Cindy. Okay. Well, obviously we're just going to be... Yeah, you know, Claudio, I'm glad you came by your first time. How did you find us? Are you just doing a search on YouTube? Make sure you pass it along, give us a thumbs up. Tell everybody, you know that you like down there, that we'd love to have everybody come out and check us out and hang with us. Very exciting having you guys all here. Alan Dior, how are you? Nice to see you. I think Alan is a new face as well as Claudio. Yep. And for the new faces, this area in the upper left is our telescope control. That right there is our telescope in the building along with its computer. This is our main view, and this is the camera control system over here. So we take pictures, and every photo we take that we stack and make a final picture, we send up to our database. Our database is available at SkyTourLive.com. It's our portal into what we do. And SkyTourLive.com, listed right there, is our wonderful site that allows you to get not only the database, where you can see within seconds of them being taken every image we take, and then you can also get prints. You can have them on large canvas, you can have them on metal prints, you can have them as prints, you could get small ones, large ones. Actually, where I am right now, there's probably about 10 or 15 on the walls, big canvas prints, and it's just beautiful. Tonight I'm broadcasting, for those that may not know, I'm broadcasting from Arizona tonight. It's our location. This is the observatory out there. I'm not in there right now. I'm actually an hour and a half from there, and I'm broadcasting from a location in Mesa, Arizona. Saturday I go back to Connecticut, and so instead of an hour and a half and 80 miles, I will be 10 hours of travel and 2,500 miles away. and we get the same result. So the telescope is remotely operated from here, from wherever I am. Actually, I can run it from my iPhone, even from the simple iPhone. I could run it, which I haven't, because maybe I'm a bit of a chicken. I don't know if I want to actually try that, but I could do it.
A lot of people do that now using that ASI Air, don't they?
Yeah.
They basically do everything with their phone through that.
Yes.
I saw an interesting Ed Ting review the other day of the Celestron 10-inch Dobsonian.
Okay.
And sort of along that line of thinking is something new in telescope computer control. It's a Dobsonian telescope, conventional solid tube Dob, and instead of setting circles or digital setting circles or a full go-to system, what this Celestron does now, it has like a docking port on top of the telescope that you park your cell phone in, and you do a little alignment procedure.
Yeah.
And once it's set up through the alignment, your cell phone becomes your digital setting circles, more or less.
Okay.
It's not go-to yet, but I bet somebody's working on that also. So, you know, no more encoders, no more motors. It's just your cell phone docked to your telescope.
Well, how does the telescope drive to the object?
Well, that's why I said digital setting circles. You still push it to the object.
Oh, okay. You move it manually.
Yeah, but your cell phone serves as your setting circles instead of, you know, conventional setting circles or conventional digital setting circles. They got rid of the encoders and all that stuff.
When Daryl's talking about setting circles, he's talking about little round metal bands, round rings on each telescope axis, which are labeled with the right ascension hours from 0 to 23, 24 basically, and declination from 0 to 90 up and 0 to minus 90 down. And that's how we position things looking on the sky. Think of it as the Earth's coordinate system extended out into space. Okay, longitude, lines of longitude, which are the vertical lines going around the Earth. Instead of in degrees, they're in hours, 0 to 23, or 24 hours. And then declination is 0, looking at the equator, up to 90, and equator down to minus 90 to the south. All right. So setting circles, when properly set up, will allow you to just move the telescope to a particular right ascension coordinate. This one up here, if you look over there, you can see up there. Okay, and declination coordinate. This is hours, minutes, and seconds. Degrees, minutes, and seconds. So 21 hours, 30 minutes, 27 seconds is right where we are when we're looking at this object here, Measure 15, the Pegasus cluster, and it's 12 degrees, 2 minutes, 30 seconds in declination. So those coordinates don't change. Those coordinates are extensions of the celestial sphere extended out into space, and where they intersect the objects, those become the right ascension and declination. Now, as the Earth moves around the Sun, that won't change their locations, but as the Sun moves around the galaxy, then the positions of these stars and everything else will change. All right, and so there will be updates to the right ascension and declination given to objects. But those coordinates are pretty much, you can think of them as semi-permanent. All right, they will change again only through motions of the Sun around the galaxy as the objects change in space. Or there are also fast-moving stars, such as Barnard's star, which will go whipping, through the area, and over a period of 6 to 8 months, you can actually see its motion is taken to a different place in the sky than you saw before. Claudio, that's interesting. He says, I just believe in energy, and the sky for me today is very interesting. Many experiences with lights. Well, I'm the Mutual UFO Network's chief photo and video analyst as well, so maybe that's something that you might want to talk about. I'm hanging on measure 15 because I'm hoping it'll calm down so we can actually get a better view of it. And as I said that, this zoom is digital. This isn't affecting anything. Okay.
Mark, would you excuse me for a second, please?
Sure, go ahead.
Right back.
Yep. All right. All right, we'll try the Pleiades tonight. There we go. You watch the telescope slide around. It's going to start pointing that way. Okay. Should be high enough to capture without any problems now, but we'll see. He says, do you know ALMA project? There is, you're not talking about the submillimeter array? Fantasy says he likes to visit Atacama. If you're talking about the ALMA submillimeter array, I'm very familiar with it. My degree is in astronomy, so I'm familiar with those types of research projects. Okay. Let's do this. The moon is very bright right now. Hey, Walter. Okay, let's move up now to the Pleiades. And we'll bring that in.
Okie dokie.
There you are.
Where are we going?
Pleiades.
Oh. There they are right there.
You got it. We have a bright moon right nearby. But what's nice is, let's see how stable this is. I have a feeling the wind won't be affecting us too much, but if you notice there's some little bars on the stars. Oh, the wind is affecting. Those little bars on the stars, this is Alcyone, you can see has a little bar through it. That's because the telescope over here is in part being blocked by the roof. So we're getting a little bit of interference. So, but the Pleiades are a beautiful star cluster. And if the moon wasn't so bright, we'd be able to see some of the nebula. But we could try it. Let's try doing a 25-second shot here. Even with the moon out, we can actually adjust for that. Okay, so we are guiding, and we'll try stacking, see what we get. Okay, let's hope it came in. It's gonna be pretty bright though. Yeah, that red you see, that's actually an artifact from the observatory, because there's a camera that's actually on the end of the telescope, and that's the camera that we use. And that telescope camera has a tiny red LED. And that red LED, because the camera is so sensitive, that tiny red LED is being picked up as a reflection off the wooden edge of the building there. Dr. Fox 2000, how are you? If you guys haven't heard of Dr. Fox 2000, I suggest you go check out his channel. He is one of the premier volcanology guys. He will take you through all the current eruptions going out there, show you live video of eruptions, and he has great conversations about earthquakes. I just saw some the other day. I lurked. I didn't come in. I didn't say hi to you, Dr. Fox. My mistake. But he was talking about earthquakes and so forth. Fantastic channel. So please do check him out. Hang with him, and you'll actually learn something. Trust me. He's a great guy. I've been out there listening to him for probably, a year now, Dr. Fox? Has it been a year? Since Iceland started. I caught you on Iceland when you first saw the Geldigadelir and Fagradalsfjall eruptions. And I thought that was a really cool. And he did a marvelous job, and I was like, wow, someone who actually knows what they're talking about. I was very impressed. Okay. Pleiades is still a little low. You see the roof is occluding it a little bit, but that's okay. Hey, Michael Galea. Yeah, he says, yep, been doing it a year and a half. Awesome stuff. Oh, that's very good, Dr. Fox. Yeah, outstanding. And thank you, CND Boy, for bringing up Dr. Fox's link. Fantastic. Make sure you subscribe to Dr. Fox, guys. He is definitely one to go see for all things earthquake, volcano, and so forth. At some point, we'll get him to talk about the differences between the andesite and basaltic lavas. It's something if you're interested in that stuff. And also, Dr. Fox, if you want, you can have me on, and I'll have you on here if you want, and we can talk. But it's a cross-pollination thing, There's all good people. Jackie Bokius, how are you? I'm glad you're listening. Fantastic. You can see that our building is occluding the telescope just a little bit, so you can only see the rough hints of the nebula, which is interesting because if we go back to Stellarium for a minute, you'll see that the moon is actually not that far away. It's not that far away. So the moonlight is lighting it up. Hey there, Judy McClellan. Good to see you. Wow. Okay. Let's head back north.
I gather there's a volcano going off down in Guatemala right now.
Is there?
Somebody had a stream running on YouTube of it.
Okay.
Really lighting up the sky down there at night.
Well, I'm going to guess that Dr. Fox has been doing that. I'll bet he has. Hey there, Prow. Prow is with us. Prow is in the house.
I see that.
All right. Let's go. We are. I wonder. Okay, so that's. We should be able to come up here. I wonder if we can get to this. We can probably get to this. Alright, we're going to try this. we're going to see if we can get to the double cluster. I'm going to... Telescope's already moving, so I'm going to go back to this. Pleiades are not quite high enough. We're rushing the season here. Okay, now we'll go back to our wonderful night vision mode. Hey John G, what's up?
I read a while back about Mount Vesuvius in Italy, and you know it was the source of the explosion that destroyed Pompeii, Herculaneum.
Yeah.
But today, Naples, Italy, is very close by, and there's I can't think of the name of it. It's Italian. Flagre something or other. It's like some fields or other very near Naples. It's just all volcanic ground, and they say, boy, if it went off nowadays, you know, it'd make Herculaneum or Pompeii look like a walk in the park.
Yeah.
Because so many millions of people live there in the area now around Naples.
That's true. Okay, this is the double cluster, guys. Because I'm in the field effectively now, I mean, I don't have all my fancy lower third stuff. You can't see the names and all that. I apologize for that. Let's do a double cluster. It's H and K Persi. All right. And I see we're getting some wind as well. Well, let's give it a shot. Let's just do a 15-second shot. We're guiding now. Guiding cannot compensate for the wind. That's a problem. All right, so live stack and clear if we need to. All right, let's see if we get it. And there's our double cluster. Look at that. That's pretty. A little bit. I'm gonna see if the next one's better. I just want to catch a couple of frames without wind. Okay, there's one. There's two. That's nice. And let's now darken up our background. This cluster pair is interesting because we call it the double cluster, but what's in fact is happening is this cluster on the left, I think, is the one that's closer to us, and this one is farther. So they're like this. You know, you can't really tell. One's closer than the other, but they're line of sight to us, and it looks like they're right next to each other in the sky. You have to remember it's a 3D universe, and it's looking back in time. Everything you see in the sky, you're seeing as it was, not as it is. Even the sun. The sun is as it was 8 minutes ago. Okay, I don't want to overstay my welcome. I just want to save it now, so we have it before the wind does a number on us. Oh, okay. All right. As it is, the wind did a number on us anyway, but it's pretty. It's pretty windy out there today. And we have the Heart and Soul nebulas down here. We can check out the Heart. But I think, again, the wind's probably going to do us in, but I'll try anyway just to show you. If anything, you can see what our telescope can do. Okay, so we got that. We saved it. Now we'll go back to our 1 second night vision shot, night vision image. All right, and now let's go to the heart. There we go. Well, fantasy, if that was a question, I'd be a millionaire. I love it. Dr. Fox 2000 says Campy is showing a bit of uplift, but Vesuvius has gone quiet again.
I read somewhere recently too that they found another buried town from an eruption long before Pompeii, even.
Okay.
Like a couple thousand years older or something.
Wow.
Also buried the town, rather like Pompeii was.
That's pretty.
It goes way back.
Well, on Martinique, remember, we had a volcano there, Mount Pelée. Yeah. And Pelée killed a lot of people, and the one survivor was a prisoner in the prison. Yeah. I stood in that prison. I was in that building.
Wasn't that a Spencer Tracy movie?
I think they made a movie about it, yes, but I don't know. Maybe it was Spencer Tracy.
I seem to think it was a... I remember that. I saw that when I was a little kid.
Mm-hmm.
Pretty spooky.
Okay, Fantasy says, I was in high school, and that day we literally went over the distance from the sun to the earth. It was one of the freakiest things in my life. Freaky coincidence that it also ended up on Who Wants to Be a Millionaire, right? That's cool. Very cool. All right, we're going to move over a little bit more. I still see wind here, so, but we'll give it a shot. This is the Heart Nebula. You can't really see too much. This here is called the Fish Head. It's part of the Heart Nebula. And we're actually aiming in the direction of a lot of wind, of course, and that's problematic, but we'll make it work. We'll have fun. So what we're going to do is we're going to ratchet up to 350 in sensitivity so we can actually use less of an exposure. And let's normalize this for that brightness.
Okay, the Spencer Tracy movie was not Martinique.
Okay. That wasn't Old Man in the Sea, was it?
No, the movie is called The Devil at 4 O'Clock. Spencer Tracy and Frank Sinatra. It was about a volcano, a fictional Pacific island of Talua.
Okay.
French Polynesia.
All right. Okay, this will be a 25-second exposure.
Cool movie, though.
Yeah.
See, you got me stuck on volcanoes now.
Dr. Fox 2000, that's the guy. Jackie Bacchius says, scientific minds have convinced me I am looking back in ancient history whenever I'm privileged to see the celestial skies through the magnified technology. Thank you, Marc Dantonio, for this opportunity. Oh, well, you're more than welcome, Jackie. This is really, I'm an astronomer. It's what I do. And, I never get tired of the night sky. I never get tired of all the mysteries. I never get tired of what makes a nebula work. I never get tired of trying to figure out how black holes operate. I never get tired of figuring out how we came about on the planet. So there's a lot of mysteries out there. That's why I wrote the book, The Populated Universe. In fact, I've got 5 of them behind me that people bought. I actually had 10 to sell here at the boot camp I was at, and all of them sold. And it's basically 300 pages of conversational discussion about how we came to be, and the book's premise is that life in the universe may very well be the rule and not the exception. A little teaser, as I'm waiting for the wind to kind of calm down here at the Heart Nebula. Little teaser, I talk about how we're made of carbon atoms. And you'll notice that we're bilaterally symmetric, the same on the left, the same on the right. Why is that important? It's important because it has to do with the fact that every creature on this planet has DNA that replicates in a way that is complementary and symmetric, you know. And symmetry doesn't have to be bilateral like humans and other life forms. It can be radial, like tulips, Echinodermata, which is starfish, right? They're pentamerous, that's pentamerism there, with five-sided symmetry. And so when we look at the fact that it's all carbon atoms, carbon's the fourth most abundant element in the universe. Next most abundant is oxygen, then helium, and then hydrogen. So it stands to reason that carbon might be the basis of life. So I am kind of a carbon bigot. So the book is based on the fact that carbon life is probably very plentiful, and some of you out there are undoubtedly thinking, well, what about silicon? I heard that silicon life could exist. And the answer to that is that silicon is nowhere near as flexible. It nowhere near serves the needs that life requires. Where carbon does. Carbon can bond with 100,000, 200,000, a million different things, and the bonds that it makes can also be broken, right? With water, other chemistry, biology. Silicon, on the other hand, tends to make crystals that are somewhat inert. You can't do too much with them. I'll give you an example. Silicon dioxide. Silicon dioxide is sand. And I always tell this, and you know, I'm sure Daryl's sick of hearing it too, because I've said it before. When you walk on a beach, you know, how's it feel to know that you're walking on mostly oxygen? Because it's two oxygens and one silicon atom. The truth is, of course, the oxygen atom is a slightly smaller atom than the silicon atom, but sand is mostly gas. Kind of interesting. This isn't really starting to show very much here in terms of the wind calming down, but I'll give it a shot. We'll do 25 seconds, see where it leads. I just want to show you what's hiding in the dark here. And remember, the double cluster labeled right there is going to be on the database. It's probably already up there. Okay, so this is now going to be the Heart Nebula. This is an emission nebula, EN. Okay, and let's just get the data going here. Color correct. Look at all that nebulous detail in there. Look what's been hiding out there. It's a little noisy, and it's got, well, the stars aren't that bad, so let it keep growing and see what we get. So that's one stacked image. When you get the second stacked image, you'll notice that it gets darker right away, and the noise tends to go away. And the more we do, the better it gets. Bonnie, thank you for putting up that link to the book. That was very kind. Thank you.
Your reds do seem redder tonight.
That's because of the moon. The color correction is getting fooled by the moon, I think.
Okay.
I think this is more what it should be. And we take down the red here. So let me just do this one more time. Do the color correct.
I don't mind it. Sometimes I think the red seems to be lacking a bit.
Yeah. Fantasy says, what about mercurial-based life? Well, Mercury, again, that's not a substance that is going to easily bond with other things. So mercury-based life is right out, as they say in the United Kingdom. That's right out. In fact, again, to understand what atoms are most like carbon, you have to look in the column that's that where carbon is. You have carbon, and right below it is silicon. Silicon is the next most capable to provide life. All right, and as it goes down in the periodic table, the elements are rarer. Okay, and to go from one row to another is actually quite a leap in availability in the negative direction. So silicon isn't as available, and also silicon is too tenacious. When it makes bonds, it doesn't like to let go. So, and it tends to make crystals, and life forms don't work when you don't have a lot of variation available, variation in chemical bonding, and that's what we need. That's what life forms require, and we don't have that ability with silicon. We have that ability pretty much only with carbon. I told you I'm a carbon bigot, so now you know why. Okay, it's carbon. Carbon's where it's at. And when I wrote The Populated Universe, that's exactly what I talk about. I talk about the prevalence of carbon. I talk about the fact that the dark nebula that you see in these nebulae, like right here, see this up here? Okay, this right here, this is these little dark nebula. This pervades the galaxy. It pervades the Andromeda Galaxy. It pervades every galaxy. It's everywhere we look. That's where life begins, and that's where stars form, is in those dark, cold clouds of dust and gas that gravitationally contract. And so when that happens, well, we can get life. But now the question is, what are those dark clouds made of? Well, they're made of silicates, silicon-based ices, as well, silicon particles, but they're also made of carbon molecules bonded to each other. And that's because they were made in stars, the outer atmospheres of very, very large red giant and supergiant stars. And that's what we see. And that's why we have so much black dust. When a supernova goes off, it spreads that dust out, and the gas keeps going. It goes back to the universe, and this is what we get. Claudio says, do you need to correct the Kelvin temperature of the video footage? What I'm doing when I color correct, Claudio, I'm actually doing a color correction, and we are trying to get to the proper color temperature for the image. It's an approximation when we're doing it live like this, but when we do it and we bring these images into Photoshop later to do formal final processing, we come up with some astonishing imagery, and I would like to be able to show you that, but I can't do that from here. I can do that when I'm back in the northeastern United States, but I don't have the ability to show that to you here without going through some gyrations. I should have thought of it before, and then I could have set it up. But you should be able to see, you should see what these things look like. They're just stunning. You know, especially when you can pull out so much detail. Alright, so we actually got away with 14 stacked images of the heart. I'll pause it. I'll save it. And then save it exactly as seen. And then we'll do one more that I think you'll like. We'll clear this after. Okay. And that one that we'll do is right below it. It's called the Soul Nebula. Heart and soul.
Star baby.
Star baby. So we're going to go now down to the Soul Nebula. The Soul Nebula is actually right here. Now, one thing to consider, we'll just do acquisition now. When Daryl says Star Baby, he's talking about the movie 2001: A Space Odyssey. Well, if you've never seen the movie, believe it or not, it's free on YouTube. The entire movie is free on YouTube if you want to go watch it. I was very good friends with the man who did the special effects for that, and Star Trek: The Motion Picture, Blade Runner, E.T., The Extraterrestrial, all those. His name was Douglas Trumbull, a very good friend of mine, and unfortunately, Doug passed away from a disease a year or so ago, and we miss him greatly. But all of the effects in 2001: A Space Odyssey were his. So it's really cool to watch what he's done and see his work. But it's free. Okay. So now, let's bring this in. Here it comes. Okay, this is the Soul Nebula. Can you see it? I know, not yet. But once we get our guide star and we start seeing numbers like we're doing now, it'll stabilize and we will do a 25-second shot of this at 350 gain. The gain is like sensitivity. You can go up to about 600. I shoot sometimes at 400, but when the moon's out, I think 350 is a good compromise. All right, and we have filters to prevent moonlight from stopping us from seeing things. Yeah, Claudia, the optics on here are quite good on this particular telescope. It's certainly not the best on the planet, but look at how beautiful this nebula is. It almost looks three-dimensional. But this is up on the database by now, so we can clear it and start going into the next one. And I'll call this the Soul Nebula, and it's also an emission nebula. And here it comes, the first one. Look at that. That's really pretty. Wow. Yes, it looks like a star baby. If you're wondering what star baby is, imagine this as being the head of a baby. There's his mouth, nose, eyes, arms curled up, and little pudgy body and little feet. It's the end scene in 2001: A Space Odyssey.
Star baby in its own right.
Well, I thought you were talking about it because of 2001.
No.
That's not why you said it?
Actually, no, I wasn't thinking of 2001 at all when I said it.
Oh.
I know there's an association with the name, but no, I see a star baby there.
Okay. I always
it doesn't look like Keir Delay, okay?
It doesn't look like Keir Delay at all. No, it doesn't. But that would be too much to ask the universe. Search some more of that dark nebula in there, guys. And again, most of these nebulae have this gorgeous, absolutely beautiful dark nebulae. When Orion comes up, and we start looking at Orion, we're going to take deep exposures of the Orion Nebula, and what's the next nebula up is called, right above it, is called the Running Man Nebula. And those two nebula are in a giant molecular cloud of dust. A molecular cloud meaning carbon compounds, silicon compounds, and that material is the stuff, again, from which stars and planets are made. So it's basically giant percolators, giant incubators for new stars and new planets.
If that looked like Kiera Lay, I'd probably start going to church.
That's funny. It does look like him. No, it doesn't. Alright, let me do something. I'm just gonna do one little thing. Oh, see here, there it is, right there. Okay. In your stream, make sure you're on 1080p, guys, alright? In case you may not be. Alright. This is again the Sol Nebula, and we've got 9 of them stacked. Let's see about getting some more detail coming out. Look at that beautiful red. The red is the emission of a tiny photon of light from a single electron that's diving back into a hydrogen atom from which it was energetically ionized. That's what happens in these nebulae. The hot star cluster here is probably responsible for causing that ionization of all this hydrogen gas out here. Jackie Buckius asks, will those nebula made of carbon and silica eventually move closer together? The answer is, if they are gravitationally bound, then they might. They might have velocity all their own, caused by their being propelled by a supernova or rotation around the galaxy. But it's possible that they will indeed, in some cases, become gravitationally bound and then gravitationally collapse. I'll give you an example. Right up here, this little tiny black object right here might be gravitationally collapsing. Maybe there'll be a star born in there eventually. There's some over here. Now, what these two are not what I'm about to say, but in space we also see areas where those have differentiated themselves into round balls, round globs, okay, like globules. And they were first found by an astronomer named Bart Bach, who actually taught me astronomy at the university where I got my degree. And those globs will become planets and stars eventually, potentially. And we've seen how in clouds like this that we can't penetrate into because there's dark nebula here. This stuff is all dark nebula. It's not the lack of nebula. There's dark dust in here that we can't see through. But an infrared telescope like the James Webb can. And when they see through that stuff, they see many, many, many more young stars forming in there than we ever knew. So we're breaking new ground on that whole front. So as you can see, this is a fertile playground for new stars and new planets. Now, we're not able to say with certainty that this location will have planets like Earth anytime soon, because this whole region is bathed in hot ultraviolet radiation that is ionizing the hydrogen gas. But as these stars interact gravitationally with each other and drift apart from each other gravitationally over time, that is going to go back to being just a cloud of neutral hydrogen gas, and dark dust once again. And then we'll get some condensations forming in stars and planets. Okay, we're at 18 stacked here. I think that's good for this. This will be the Sol Nebula. I'll hit save, and it's already on its way up to the database. We'll save it exactly as seen. It's too bad you guys couldn't see Izabela tonight. Izabela Melamed from Sofia, Bulgaria, is one of our mainstays in SkyTour livestream, and she loves to hang out with us, and she does all of the tables of contents for our streams. She'll probably be upset she missed this one. She usually is.
That's one downside of us starting earlier.
That's right.
On standard time, and as we headed toward winter with earlier sunset.
That's right.
Somebody asked about her earlier, and it was 8 o'clock in the evening here on Mountain Time, and so it would only been 5 in the morning over there.
Yeah.
I know she was up after midnight yesterday.
Yep. Hey, Counselor Gray.
Still sleeping.
Counselor Gray, out in the observatory, I'm using a Ryzen 5 processor with 6 cores, and lots of memory, and that's able to run everything. So far, that computer has been perfect. Keep in mind that, you know, when you're running a system out in the middle of a building like that, you got to keep critters out of it. You know, the mice can't get in it, so there are mice out there. Obviously, there's mice and that can get into any building. So you have to add meshes that will prevent that from happening, but won't stop the air from getting in to a computer. It's actually quite elaborate to do it, but it's all right. It worked fine. I did have mice in one of my SkyTour East computers at one point. SkyTour Livestream East is the East Coast Observatory. This is SkyTour Livestream West. And I don't know what to call the third observatory if we get the third one. SkyTour West and a half? I'm not sure. But we'll see. Alright, so that was the Sol Nebula. I hope you enjoyed that. Now, what I wanted to do was to just say, I think at this point, with the moon up, as the nights wear on, we're going to actually be able to have less interference with the moon. Okay? But as it is, the moon is pretty bright right now. Now, as you can see, it doesn't much matter for this faint nebula because we're using special filters that allow in only a slice of the light that the hydrogen emits in the red, a slice of the light that the oxygen emits in the greenish blue, and a slice of the light that sulfur 2 emits in a reddish hue as well. So we're actually using a combination of what are called narrowband filters, but it's all in one filter.
You're using sulfur filter?
Well, the combination, the UHCS, I think, has the sulfur 2 band that it's passing through as well. It's sort of like huh?
If I knew that, I forgot.
Okay. All right.
I mean, it's not like you're doing the Hubble palette, though.
No, you can't do the Hubble palette unless you do separate filters.
Right.
Which, by the way, the next telescope is going to have that filter wheel on it to do the Hubble palette and do the separate filters. So it'll be kind of fun. All right, guys. Well, look, this has been a wonderful night. We have been going now for 2.5 hours, and I want to thank you for coming out and we will be back on the next clear night for sure. So thank you, and we will talk soon enough. Daryl, did you want to have any parting words with everybody before we go?
No, you kind of snuck up on it.
Well, I did mention this was that we're going to go to this object, last object, but that was about 20 minutes ago.
Okay.
Yeah.
Well, no. Thank you for coming, everybody. I hope you had a good time, and good night.
I think they did.
See you soon.
Yeah. All right, guys. We'll see you on the next round. Until then, keep looking up, and we will be looking for you.
Excuse me.
All right. Well, good night, Daryl. Thanks for coming.
Thanks for having me.
Of course.
Good night, everybody.
See you, everybody.